So now I am delighted to introduce our first keynote speaker of DataFAIR, John Wilbanks. John is a senior advisor at the Milken Institute's Faster Cures and a senior fellow at the DataFAIR initiative. He's a distinguished authority in the field of data governance, backed by a wealth of experience and forward-thinking vision regarding the future of data and AI. In his talk today, he's going to shed light on the hurdles and prospects of effectively implementing data governance strategies that will really unlock the potential of Gen AI. So John, without any further, I'd like to give you the floor, and I look forward to hearing what you have to say. John, are you on?
Hello, can you hear me?
Yep, there you are.
Great. Hi, everybody. Thanks, everybody, for the invite. Thanks, AJ, Elucidate. I'm happy to be here. It's always great to be at any event that has the word FAIR in it, if you're me. And so since this is a keynote and we've got lots of details, and to be blunt, I am not a technologist. I'm fundamentally a governance person. And I've most recently come from running the data office at Biogen Digital Health. So I had a pretty significant view on the operations of doing a lot of digital health and data-driven work. And so that's really the cultural context I'm going to be talking out of, because I think a lot of the times we don't think about the regulations and the legal structure and the governance around here. And to me, FAIR, and I'll talk about what that means for those of you who aren't familiar with it, FAIR is a way to think about data governance that is really, really relevant to what we're going to be doing as we start to train large language models, other kinds of machine learning models on larger and larger data sets. Next slide, please. So, when we talk about FAIR, I want to be very accurate. And so this is the exact article that created the FAIR guiding principles, right? So FAIR stands for findable, accessible, interoperable, and reusable. And the idea was to build on some of the innovation we've seen in cultural space, in text, in photographs, and elsewhere that have come from open licensing. And so when you're dealing with data and open licensing, it's not really a clean fit with the kinds of things we've seen in culture or in software. And so these FAIR principles are an attempt to construct a data governance regime that creates innovation, peer production and innovation, so that someone who is depositing a data set can come along and find someone else's deposited data set, combine the two, and design something new. Because this is how we have remix culture in photographs, blogs, what have you, but also remix culture in software and open source and free software. Next slide, please. So when we're doing culture and software, right, these are the adjacent possibles that everyone reasons out of. And so I've got the Linux Penguin and the GNU license for the GPL. I got the open access icon and the Creative Commons attribution by icon. So the software commons on the left was the real inspiration for a lot of the stuff that winds up being FAIR data. And it was around this idea that when you have software, the core governance regime you need to worry about is copyright. Copyright governs all sorts of stuff that you do on the internet, like copying and redistributing any kind of copyrighted work. Open access is the application of that concept to the scientific literature, saying the literature is copyrighted because basically anything that we fix in a medium that has selection and arrangement and is a creative work gets copyright. So the Creative Commons attribution license is the legal tool that then inverts all of that copyright protection and guarantees availability. And so in both of these cases, what you've seen for many years in software is sort of explosive development and innovation and reuse. And what you're trying to construct on the right-hand side is that kind of explosive development and reuse in the scholarly literature. And one of the things I think you'll see pretty quickly is the use of the open scholarly literature as a training input to large language models. And indeed, the Microsoft BioGPT is itself trained on that corpus specifically to create a search engine to the medical literature. Next slide, please. But today, we're not talking about the literature. We're talking about generative AI and FAIR data. And so copyright, which is where almost all of the legal regimes that are robust and international and harmonized, copyright doesn't apply to the vast majority of science. Copyright does not cover facts, ideas, systems, methods of operations, inventions, or discoveries. right? Copyright is limited to these creative works, going back to the very creation of copyright. And so using the GNU GPL, using the Creative Commons licenses on data is equivalent in a lot of cases to simply putting that post on Facebook that says, Facebook doesn't own what I'm posting here. You can write it, but it doesn't matter. And so again, that FAIR concept was saying, if we can't use these licenses, we can create principles that say the data needs to be findable. You need to be able to search for it. Accessible, meaning that it needs to have lots of metadata available on it. Right? Interoperable, the idea that it's done in as much of a standard as possible. That you don't have any sort of blockages to getting access to the data beyond maybe an authorization system. So copyright licenses can do almost all of that if you add them to the internet. We need these FAIR principles as a way to manage essentially that same kind of innovation commons out of data. Next slide, please. Now, oh, I hope that didn't get cut off. Let's see. Okay, there we go. So I had my choice of slides to sort of, or pictures to pick from here, but even I was shocked at the scale of investment in AI in 23 already. So, right, this is about a month old. And so as of, 3/4 of the fiscal year so far, we had a 400x increase in generative AI funding compared to all of last year. And so what you see is an investment bubble. AJ referenced this in his slides, right? The investment bubble and the relentless hype cycle are real. They have a significant impact. You're seeing multiple models. So up here alone, you see the 4 big models, but there's an enormous amount of open source modeling happening. And from a governance perspective, most of these large language models do not prioritize governance. They do not prioritize provenance. They don't prioritize chain of custody or many of the things that are needed if you're going to do regulated work that is driven off of machine learning and statistics. And instead, most of what you see from a governance perspective is what I would characterize as move fast and deploy. This is a slight improvement over move fast and break things, but only a slight one. Next slide, please. So when you put together an investment bubble, a hype cycle, and move fast and deploy, what you get in the cultural space is copyright violation, and that tends to bring copyright suits. So these are only 2 copyright lawsuits. You can relatively easily find more. And what they show you is elite authors on the left on one side, large holding companies on the right, suing 2 of those big bubbles from the last slide for copyright violations. And this is because they did not train on data that the authors or the owners feel there was permission to train on. Now, going back to that Creative Commons icon back there on the open access slide, the idea behind the open access literature is specifically to allow this kind of training. So you have this unambiguous right to build on something that's coming out of the open literature. But John Grisham, who's a very famous author in the United States, George R.R. Martin, who wrote Game of Thrones, did not license their works openly. So there's going to be a big, what we call lawfare instead of warfare. There's going to be an array of lawsuits that are going to be going to a variety of venues in the United States and elsewhere, challenging the right to train, right, as a copyright violation. So we should expect this in our space, and I'll go into some of the issues in health and medicine in a second. We should also expect things like this, and I'll come back to that later, but this concept of lawfare is going to be something that is going to be a feature of the generative AI space in health and medicine, not a bug. Next slide, please. So we can again say, what can we maybe expect? What's the adjacent possible and what's next? And I would call this software. And so we have 2 tools released within the last 30 days alone, each of which allows artists to poison or otherwise metadata mark their work in ways that destroys generative AI's ability to clone their work or to replicate their work as an output. This is really interesting because how do you delete the vectors and the mathematical markers that you learned from the poisoning inside your tool? That's going to be something that needs to get built technically. But this concept of you're going to have both a legal governance pushback and you're going to have the people who feel hurt by the AI are going to be pushing back as well. And I think both of these are coming for us in health and medical AI, and we need to be thinking and talking about those from the beginning in our governance so that we can make strong claims, use these kinds of systems in ways that actually help people. And the way that, next slide, please. And so the end game of this is, I looked for AI self-regulation, and like all I found were memes. So here's, my favorite of the memes. So this is Sam Altman. He runs OpenAI. And between the sort of rise of open source and small crowd peer-produced systems and this emerging lawsuit and software culture, what you see are the large companies that have lots of money saying, please regulate us. This is despite the fact that we know self-regulation typically does not work. It has almost never worked in the last 20 years of technology. It is typically done to prevent stronger regulation, or at the same time, in the ideal world, it both prevents stronger regulation, but it also creates a moat, which makes it much harder for startups or open source software to jump in and start making good claims coming out of these kinds of systems. So my hope is that in what we're talking about today, that we do not wind up in this spot, because this is not a great spot to be in, where you have the most important people, the providers of training data, the elite authors, wanting to poison the system. You have the training authors wanting to sue the system, and we do not have a meaningful regulatory regime that we can use to even think about this. This is the worst space. Even all the money in the world does not make this the right space we want to be in. Next slide, please. When you start to look at this in our space, you see a lot of happy things posted in the press. You also see a lot of happy things posted by consulting firms who can make a lot of money. When you start to click down underneath it, it's really interesting how many pieces of the data-centered health AI system are starting to resemble the large language models and the large image models that we've seen in consumer. Next slide, please. And I've provided, URLs wherever possible. I'll make all my slides available so you can click and find these. Right on the left, end of last year, we have an article that's kind of a scoping review, looking at the progressive outputs of a generative AI model to produce fake chest rays. This was in the context of synthetic data. So, and I think this is more computationally similar to most of us on this call than we have $10 billion raised so that we can go crazy with all of our computers and training. So you're looking at 14 hours just to produce the 4 X-rays on the right under late 2022. And on close inspection, they are easily recognizable as being fake. So as of late 2022, we do not have the really accurate synthetic training data conceptually in this kind of space. By the middle of this year, we see NVIDIA advertising the creation of infinite medical imaging data with generative AI. This is not a critique of NVIDIA. I'm a big fan of NVIDIA. I've been a big user of NVIDIA, but you sort of see how quickly we go from the kinds of claims that we evaluate in science, because the claims we evaluate in science are at least usually subjected to peer review, versus the kind of claims we make in marketing and advertising, which are not typically subject to peer review. Next slide, please. One of the most common things I've heard proposed that we should be doing, and something that I support in a lot of conceptual ways, is I should be able to take my electronic health record and upload it to ChatGPT and have it tell me what's coming back out of it. And so this is a very recent communication to Nature. And what you see is essentially that these large language models, unsurprisingly given their training data, can recapitulate really, untrue things, and things that are not only untrue, things that are untrue because of race specifically. Next slide, please. So I want to start with, proper respect, which is that almost all the models gave appropriate reactions to what's the genetic basis of race, because again, the scientific consensus is that race is a social construct, so that's good. Go ahead and advance the slide, please. Right, here's an example of something that's tough, right? EGFR, right? These are systems where historically there have been race-based medicine practices that have been scientifically refuted. This reveals the biases of the training data and the fact that these models do not have a semantic concept of good vectors or bad vectors, just likelihood that the vector is a sufficiently predictive next vector to put out there. Next slide, please. Just sort of noting that this happens again and again. Right here, we have instead of EGFR, we have normal lung function and normal lung capacity. Interestingly, when you add race, it fails. When you delete race, it does not give race-based answers, which I thought was interesting. Next slide, please. And of course, beyond any of the training data issue, there is the hallucination issue, which is that the models are fabricating equations in multiple instances for both of these areas. Next slide, please. Unlike ChatGPT, I think we have the benefit of, in our spaces, if we're going to make claims about patients, or if we need to go to the FDA, if we're going to make claims in the healthcare systems, we're going to go into a regulated environment. And so I would encourage everyone to check out this FDA discussion paper and request for feedback on using AI and ML in the development of drug and biological products. It's got a lot of context. It gives you a sense of, again, unlike in culture, we have an empowered regulator. That regulator has been in learning mode for years on these kinds of technologies, whether it's software development, so how do you do agile development that's fully compliant with GCP, right into this. If you dig into the discussion paper, you will see the standard that I've copied on the left from ASME. Unfortunately, you have to buy it. That's a whole nother complaint I would make about, the government should not be pushing standards that aren't free, but that's a separate speech. But this is the standard that they are going to be building off of. Again, in governance space, we usually build off of the adjacent possible. And so this is looking at computational modeling as applied to medical devices as a beginning kind of framework. So if you're in the space and you want to be selling to somebody or using in a context that's going to eventually make a claim to a regulator or touch a patient, I would encourage you to read these two documents. Next slide, please. Right, just to sort of note with the paper on the left that the paper I noted above is not particularly unusual. You can find all sorts of proof, again, structured evidentiary materials methods available that just show over and over again the impact of the biased training data on the model. So all of these models are likely to be biased because of how much bias is systemic and structured in the information space. We owe it to ourselves to make sure that we think about that and correct for it. It's not a reason not to train, but it is a reason to pay real attention to how we train and what we train on. And on the right, what you see is this blueprint for trustworthy AI governance, which is a really important document for the Coalition for Health AI. This is feeding into emerging White House planning. And so I would encourage you to take a look at that document as well. Next slide, please. So going back to, who are the authors here, right? In ChatGPT, it's the authors and the owners of author copyrights who are suing. And I think for us, it's patience, right? There's a growing movement that recognizes that individuals need to control their own health data or own their own health data, that it shouldn't be a privatized resource of the companies. And there's a patient movement, right? Holding technology companies and medical companies accountable. And this is my friend Andrea on the right. There is not going to be a lot of tolerance in the patient community for training without consent and training without context and training that doesn't address some of these issues that I've been talking about through the article. And so, when you think about, next slide, please, there's going to be lawfare coming here as well. So in EU, you have to provide to every citizen the right to be forgotten, the right to be deleted. I love this article on the left because it talks about machine unlearning, which is this concept of having to delete the vectors that you learned when that person retrospectively demands to be removed. On the right, I have a note from a prominent law firm around the California Privacy Act, which basically guarantees anyone on whom you have drawn any inference on personal data to inspect that inference. Compliance on both of these is going to be really expensive. And again, if you don't start from the perspective that you need to be able to unlearn some things, you need to be able to provide transparency to people in the data, it's going to be very hard to comply with both of these and the FDA if you don't start from the beginning by complying with the right to be forgotten, transparency, and the FDA's work. And the FDA's work is really around chain of custody, validation, provenance, all of the stuff that is really relevant in where we started this talk. Next slide, and I'm almost done, I promise. So I want to bring it back to FAIR, which is if you start from the idea that you should only be training on FAIR data sets, right? Things that have a persistent identifier so that they are findable. things that are not overly restricted so that they can be resubmitted to a regulator or to even a customer during their diligence. If you've chosen some bespoke data format or some bespoke model, you're not going to be able to have as much conviction when you do your claimings. And then it really is that reproducible that I think drives a lot of this. The more that the data you train on can move with the model you trained, that can move with the code that shows how you've addressed for bias, how you've addressed for training set disparities, how you're managing the right to be forgotten, how you're managing all of these animals, right? The FAIR principles, right, as a filter for the training data that you're looking at, as a contract structure for how you share data with a third party, as a contract structure for how you bring in data to train on that's private, are a really good protective governance framework to start from. Because they give a way of thinking that says, from the beginning, I'm going to be inspected. I'm going to be held to a higher standard, right? I'm not ChatGPT. And hopefully we get to a point where we're not getting sued and we don't have patients putting up fake data to poison the models that all of these smart people are trying to build. Next slide, please. So my ending point, because I like to end with some pictures and get you thinking, is that when you find a data set on the internet that looks perfect for your model, you can feel like Alice in Wonderland. And when these are two stills from the movie in 1951. And you take one of these and you eat them and you eat that data. And in the old sense is garbage in, garbage out in technology. The thing about these models is it's not garbage in, garbage out. The garbage inflates you because it builds the model and then you build on the model. It's much more like building a skyscraper on top of a landfill in an earthquake zone if you haven't got the data governance settled before you start training. And so be very, very careful when you find that perfect data set, next slide, so that you don't wind up looking like Alice after she eats the wrong cookie. Because this is how I feel the cultural LLM and image models, this is what they're dealing with right now. And it's not a space we want to be in when we're talking about claims we make to patients and to regulators. Last slide, please. So 2 things I would ask you to take away, right? Be careful what you ingest, right? It doesn't mean don't ingest, but don't be Alice, right? Be smart. And the second is FAIR is a way, if you do it right, FAIR is a structure and a mental model that helps you protect patient privacy and maintain a reproducible chain of custody. And if you do those 2 things, compliance with the emerging FDA, compliance with emerging HHS will be relatively natural. If you try to put patient privacy and reproducible chain of custody in at the end, it won't work. It'll break business logic and you won't be able to find the money to do it and you'll be stuck. So my hope is that I have convinced you that, that this is worth thinking about, this is worth prioritizing, but that it's really important that you keep going and you don't stop with the innovation because we need these tools. But just be careful because eventually we're going to all get audited. Thank you so much.
Thank you so much, John. That was an awesome presentation. We've actually got some really great questions in the Q&A, and I want to start with one that I was thinking myself when you were talking about the differences of the between the art community and the science community, and I think you summed it up really, really well in your talk. But this middle one here is really sticking out. Art and science communities work fairly differently, especially with respect to the ownership of output. Do you foresee the biomedical community pushing back against feeding AI? And you kind of touched on that a little bit with your talk about like the right to be forgotten, but I would just love to hear you kind of expand on that for a few minutes.
So that's a great question. Thank you, anonymous attendee. I don't know, right? So I had a whole piece of the talk that I cut around, is the output of ChatGPT copyrightable? Because A, I knew I was going to run over, and B, it was a little irrelevant. Because there's actually a lot of case law that says the output of copyright of these AI systems is not in fact copyrightable because no human made it. Right? So there's the monkey who took a picture of itself. This is one of the very famous cases. There was another one which was sort of a cult, and they claimed that their divine book was written by a celestial being, and so therefore it wasn't copyrightable. And there's all this case law that says actually, if a machine makes it, it's not a human work, and copyrights for human works. But there's this concept that if you can use the AI to produce a work that looks like Monet, it might infringe Monet's estate in some way, right? And so I think that's going to get figured out in court. The thing that I'm curious about in science is would I, as like, if I'm like the top P53 cancer researcher and these models start writing fake papers, I'll be pretty mad, but it's going to be a misinformation problem, not a copyright problem. And you're already
Yeah.
starting to see this, in which, around when the new vaccines come out or new products come out, these things are really good at writing bullshit really, really quickly. And it looks plausible because it follows all the patterns of plausible communication. So I think you'll see a pushback against that as well. On the feeding AI thing, I don't think the scientists are going to have much of a problem with it, because if it is useful to them as a better search engine,
Mm-hmm.
then I think they'll use it, right? Our search engines are archaic because the search engines for the web search by links. Guess what we don't have in scholarly literature? Hyperlinks. So it doesn't work very well. I think the pushback is going to be on the patient side, as I noted, and I think it'll be. I think this concept of data poisoning is so simple, and if you don't go look at the article, it's literally adding metadata tags and other bits of information to fool the AI into adding giant ugly splotches whenever anyone tries to clone that artist's work. And it will always be easier to poison systems than it is to clean systems.
Right.
So,
Yeah.
but I think it's a great question, and I think part of it is, what do we mean when we say biomedical community?
Right.
Because the patients and the scientists have different perspectives.
Very different desires for what they want to see come out of these tools, right? You could imagine patients want access to the data, understanding of their own data, right? They don't have necessarily the background to interpret their own medical records the same way that a scientist would, and they may delve different things. So it is competing interest for sure. So John, I have a couple more questions that are in the chat. I'd ask you to, if you don't mind typing out those answers there. And then I know that you referenced a few papers and articles. I'm sure our attendees would love it if you have the links handy, if you could share them as well. And we can make sure that they go out in email.
You're welcome to share the deck there. Everything I mentioned in there has a URL in the slide deck.
Oh, fantastic. Yeah, we'll definitely send that out in the email to everybody. John, thank you so much. Awesome presentation. Really great to have you here. Appreciate that.